all you need to do is listen, breathe, and drift. And if these calm explorations help bring you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, find a comfortable place, close your eyes, and let's begin our quiet journey to Stephenson 2-18. Fact 1. The quiet birth of a giant. Long before Stephenson, 2-18 became a star, it existed only as a whisper in a vast cloud of gas and dust. In that ancient cradle, gentle ripples of gravity began drawing scattered particles closer, gathering them the way dew collects on a cool morning leaf. Slowly, over millions of years, the cloud thickened, warmed, and brightened from within. What began as a faint shimmer grew into a rising glow, the earliest heartbeat of a star, far more massive than most that share our galaxy. Even then, its destiny was written in its enormous size. It would shine fiercely, live briefly, and grow to a scale so wide it would challenge imagination itself. In this quiet beginning, Stephenson 2-18 took its first breath of light, and beyond that breath, its story continued to unfold softly in the dark. Fact 2. A star among 1,000. Stephenson 2-18 wasn't born alone. It emerged within a crowded stellar nursery known as Stephenson 2, a cluster thick with newborn suns and glowing giants. Here, stars share their early years like siblings learning to shine, their light weaving together into a soft celestial tapestry. This cluster is unusually rich in red supergiants, making it one of the most dramatic neighborhoods in the galaxy. Among these ancient swollen stars, Stephenson 2-18 quietly stands as the largest and most luminous of them all, not by shouting for attention, but simply by existing on a scale that dwarfs everything around it. Surrounded by companions, it grew without haste, expanding gently into its enormous form, drifting like a lantern in a crowded sky. And nestled among these stellar siblings, its glow continued to strengthen, preparing it for the role of the cluster's gentle giant. Beyond this warm gathering of stars, its journey continues deeper into the vastness. Fact 3. The dusty cradle of Stephenson 2. The region where Stephenson 2-18 was born is wrapped in thick layers of interstellar dust, soft, drifting material that dims starlight and turns cosmic landscapes into a dusky red haze. Through this veil, the cluster's glow becomes muted, as if the universe placed a soft blanket over it to help it rest. This dust is made of carbon, silicates, and ancient minerals from generations of stars that lived and died before. In it lie the quiet memories of supernovas, long faded, each grain a tiny echo of cosmic history. Within such a cradle, young stars form slowly, shielded from the harsher radiation of the galaxy around them. Stephenson 2-18 grew inside this gentle enclosure, gathering warmth, shaping its immense identity, and beginning its long drift into visibility. And beyond this dusty cocoon, the star would soon reveal its first true light. Fact 4. How a red supergiant begins. Every red supergiant starts as a bright, massive star, burning through its fuel far more quickly than calmer suns like ours. Stephenson 2-18 began its life shining fiercely, its core hot enough to fuse hydrogen into helium at an astonishing rate. Over time, as its central fuel dwindled, the delicate balance between outward heat and inward gravity began to shift. The star responded in the only way a massive star can, by swelling outward, its outer layers drifting farther from the core like warm breath expanding into the night. Its surface cooled as it grew, giving Stephenson 2-18 its deep red glow, a quiet hallmark of this later stage of stellar life. And in this gentle expansion, the giant began its steady transformation, preparing for the size it would one day reach. Fact 5. The slow gathering of stellar breath. A star as enormous as Stephenson 218 doesn't simply grow. It breathes. Its outer layers rise and fall in cycles that can last months or even years, as if the star itself were taking long, slow inhalations of light. These motions are driven by convection, warm material rising, cooler material sinking, creating vast, drifting patterns across its surface. Each breath carries energy from the core outward, releasing it across the star's vast atmosphere. This process is gentle but powerful, shaping the giant's structure and influencing how it shines. If you could float near its surface, these motions would look like rolling continents of glowing gas, drifting in slow, dreamlike waves. With each quiet pulse, the star grows more luminous, more expansive, and more serene in its enormous presence. Fact 6. A glow. Born from gravity's patience. Gravity is the silent sculptor of stars, and with Stephenson 218, its work was patient and profound. Over millions of years, gravity pressed inward with steady hands, compressing the star's core until nuclear fusion ignited. That ignition created an outward pressure of light and heat pushing against gravity's pull. The result was an exquisite balance, a glowing sphere held in perfect tension, neither collapsing nor exploding. For a star as massive as this one, that balance is delicate. Small changes in the core ripple outward with immense effect, shaping the giant's eventual fate. Yet for now, gravity holds Stephenson 218 in a gentle equilibrium, allowing it to shine with deep, steady warmth. And from this quiet stability, the star's story continues to unfold like a slow cosmic exhale. Fact 7. The deep red of ancient fire. Stephenson 2018 glows with the soft, dusky light of a red supergiant, a shade shaped not by flame, but by temperature. Its surface is cool by stellar standards, only a few thousand degrees, allowing deeper, richer hues to shine through. This soft red color is the quiet signature of a star nearing maturity. Its brilliance mellowed like embers that warm rather than scorch. If you could see it up close, its light wouldn't be harsh or blinding. Instead, it would feel warm and diffuse, like the glow of a distant sunset stretching across a vast horizon. The redness is a whisper of age, a sign that the star has entered a slower, fuller chapter of its life. And with each gentle shimmer, the giant drifts deeper into its peaceful crimson glow. Fact 8. The long childhood of a massive star. Though massive stars grow quickly, Stephenson 218 still spent millions of years in its stellar childhood, shining blue-white and fiercely bright before expanding into its current state. During that early era, its core worked at an extraordinary pace, fusing hydrogen at rates far beyond what our sun will ever achieve. These early years shaped everything that followed: the future expansion, the eventual color change, and even the star's quiet destiny at the edge of its life cycle. It was youthful, powerful, and radiant, but its size guaranteed a brief life compared to smaller, steadier stars. Yet even in its youth, Stephenson 218 held the promise of the giant it would become, waiting patiently to unfold into its full red brilliance. And when that long childhood ended, a new, gentler phase began. Fact 9. A life measured in burning light. For stars, life isn't measured in years, but in the fuel they burn. Stephenson 218, with its immense mass, burns through its nuclear energy at a breathtaking pace, consuming in a few million years what our sun will burn in billions. This rapid consumption is why massive stars expand into red supergiants so quickly. Their cores evolve swiftly, pushing the outer layers outward. But even though its life is short on cosmic scales, it's full of profound beauty. Every moment is marked by powerful fusion reactions, soft outward pressure, and a glow that travels through space for tens of thousands of years before reaching us. Its story is written in light, bright, warm, and endlessly drifting through the vast dark. And beyond that light, another chapter waits quietly to unfold. Fact 10. Why some stars grow so large. Some stars are simply born with more material, more dust, more gas, more gravity to shape their fate. Stephenson 2-18 began with an extraordinary mass, giving it the fuel to shine intensely and the pressure to expand into one of the largest stars ever measured. Its vast size isn't a sign of strength alone, but of a delicate balance between what it burns and what it releases. As its core changes, new layers ignite, pushing the star outward like a slow, blooming flower of fire. Massive stars like this don't stay small for long. They are destined to stretch themselves into colossal forms as they age. And so, Stephenson 2-18 grew, wide, warm, and impossibly gentle beneath its deep red glow. Fact 11. The largest star we know for now. Stephenson 2-18 is often considered the largest known star by radius, a title it holds with quiet grandeur. If placed at the center of our solar system, its surface would drift far beyond Jupiter's orbit, filling the sky with a soft, glowing red horizon. This staggering scale is almost impossible to imagine, even for astronomers who spend their lives studying such wonders. Yet despite its immensity, the star is not violent. It expands with the calm patience of a slow cosmic tide, its surface drifting outward like a warm mist. Its sheer size challenges the limits of what a star can be, stretching our understanding of stellar evolution. And still, in the vastness of the universe, stars like this may be waiting to be found, hiding softly behind dust and time. Fact 12. A star wider than imagination. To understand the width of Stephenson 2-18, imagine traveling in a spacecraft at the speed of light, the fastest speed in existence. Even then, it would take more than 7 hours just to cross from one side of the star to the other. That distance is filled with swirling gas, drifting plasma, and gentle convection currents rising like luminous waves. Its outer layers are so extended and diffuse that they resemble a warm, glowing cloud more than a solid surface. The boundaries of such a star are soft, fading gradually into surrounding space like a candle's halo dissolving into darkness. Stephenson 2-18 doesn't just exceed imagination, it redefines it, reminding us how vast and varied the universe can be. And beyond that immense size, more mysteries continue to drift outward, waiting quietly in the dark. Fact 13. Light crossing the Titan. Light is the swiftest traveler we know, crossing the vast emptiness of space at nearly 300,000 kilometers every second. Yet even at this unimaginable speed, it would take hours for a single ray to journey across the enormous width of Stephenson 2-18. This means that when we look at the star, we're seeing light that began its journey at different times across its sprawling surface. Some photons began their escape when the star was gently shifting, others when it was slightly dimmer or brighter. Together, they paint a soft, blended portrait of a star too large for any single moment to capture fully. It's as though the star stretches time itself, turning its glow into a slow, luminous echo. And beyond those hours of travel, the light continues on its quiet way toward us. Fact 14. If our sun were this big, if our sun suddenly expanded to the size of Stephenson 218, the solar system as we know it would disappear into its warm, diffuse layers. Mercury, Venus, Earth, Mars, and even Jupiter would all be deep inside the star's atmosphere, drifting like tiny grains within a glowing sea of red plasma. From within, the sky would not be blue. It would shimmer with soft, fiery haze. Yet despite its size, Stephenson 218's outer layers are extremely thin compared to our sun's compact surface. They are cool, gentle, and spread wide like a lantern's fragile glow. The star is immense, not because it is dense, but because it stretches its energy outward with quiet patience. This comparison reminds us how small our home star truly is, and how beautifully varied the universe can be. And just beyond this imagined transformation, another perspective awaits. Fact 15. A sphere beyond all familiar distance. To understand Stephenson 218's radius, astronomers compare it to familiar distances: the Earth-Sun gap, the orbit of Mars, the path of Jupiter. But none of these truly capture its enormity. The star's radius reaches millions of kilometers outward, forming a sphere so expansive that planetary scales begin to lose meaning. It is a world of gas, heat, and drifting plasma, layered like soft ripples in cosmic water. The star's form isn't sharp or rigid. Its edge fades gently, the way fog dissolves into morning air. Each layer is slightly cooler, slightly thinner, until the star's identity blends seamlessly into space. This softness makes stars like Stephenson 218 feel more like living clouds than solid spheres. And beyond that hazy boundary, the universe continues to open like a calm, starlit sea. Fact 16. A surface that lives in slow motion. The surface of Stephenson 218 isn't a solid boundary like the crust of a planet. Instead, it's a vast, drifting ocean of glowing gas that moves in slow, rhythmic patterns. These motions can take months to unfold, creating the illusion of a star that lives its life in a gentler kind of time. Waves of brightness rise and fall, shaping subtle patterns across its enormous face. These surface changes are caused by convection, warm gas lifting upward, cooler gas sinking inward, but on a scale that stretches comprehension. Each rising plume could engulf entire planetary orbits. Seen from afar, the star would appear to shimmer softly, as though wrapped in a luminous breathing veil. And as those quiet waves drift outward, the star continues its slow, glowing dance. Fact 17. The gentle swell of stellar winds. From its surface, Stephenson 218 releases steady streams of material into space, a phenomenon known as stellar wind. But unlike the harsh solar wind emitted by our sun, the winds of a red supergiant are softer and more diffuse, like a warm breeze rising from a desert at dusk. These winds carry dust and gas outward at millions of kilometers per hour, yet feel peaceful across such immense distances. Over time, this constant outflow shapes a delicate shell around the star, slowly building a cocoon of enriched material. These stellar winds are part of the star's final gift to the cosmos, sending future building blocks of planets and life drifting into the galaxy. And beyond these drifting winds, the star's story unfolds with quiet generosity. Fact 18. Layers upon layers of hot quiet. Deep inside Stephenson 218 are layers of fusion, each burning a different element as the star ages. Closest to the core, hydrogen has already been consumed, giving way to helium and eventually heavier elements like carbon and oxygen. These layers form like the rings of a tree, each one a chapter in the star's evolving life. Yet despite the intense energy at its center, the outer layers remain calm and spacious. Energy travels outward slowly, spreading through material so extended that it can take thousands of years to reach the surface. By the time light emerges, it has been softened, shaped, and cooled by its long, patient journey. And from those gentle layers, the light drifts into space, carrying with it the quiet signature of a giant nearing its twilight. Fact 19. A diameter wrapped in starlight. The true diameter of Stephenson 2-18 is difficult to measure, not because it is small, but because its edges fade softly into space. Unlike a planet, which has a clear boundary, a red supergiant's outer layers are diffuse and glowing, blending gradually with the darkness around them. Astronomers must look for the point where the light begins to thin, a gentle threshold rather than a strict line. This means the star's diameter is more an estimate than a certainty, wrapped in layers of shimmering plasma that stretch outward like a slowly dispersing cloud. Even with the best instruments, its size appears more like a glowing blur than a crisp sphere. And beyond that hazy reach, its starlight continues drifting through the cosmic night. Fact 20. What too big means in astronomy. Stephenson 2-18 is so enormous that it challenges some of the assumptions astronomers once held about how large a star can grow. There is a theoretical limit, the Hayashi limit, that describes the boundary at which a star becomes too cool and too wide to maintain its delicate balance. Stephenson 2-18 approaches this frontier, existing in a region where the rules become soft and uncertain. This star reminds scientists that nature does not always behave neatly. Its immense radius suggests a structure so extended that it borders on instability, its outer layers tenuous and easily stirred by convection and wind. Yet somehow, it continues to hold its form, glowing gently against the laws that seem to constrain it. And in this quiet defiance, the star shows us how flexible the universe can be. Fact 21. The soft red glow. The light from Stephenson 2-18 reaches us as a deep warm red, the color of slow-burning embers. This hue comes from its surface temperature, which is much cooler than that of hotter, blue-white stars. At just a few thousand degrees, its light shifts to longer wavelengths, giving it a soothing, sunset-like glow. If you could stand on a world orbiting near the edge of this giant, the sky would be awash in soft crimson, illuminating everything with a gentle, dreamlike warmth. No harsh glare, no blinding brightness, only a warm radiance spreading across the horizon like a permanent twilight. And as this red light drifts across space, it guides us gently toward the next chapter of its story. Fact 22. Light from a cool, fiery heart. Although Stephenson 2-18 shines with the warmth of a gentle ember, its heart is unimaginably fierce. Deep within its core, temperatures soar high enough to fuse helium and heavier elements, releasing energy that slowly threads its way outward. By the time this energy reaches the star's surface, it is cooled into a soft red glow, warm, welcoming, and deceptively serene. This contrast between the star's peaceful exterior and its fiery inner world is part of what makes red supergiants so captivating. They live with calmness on the outside and quiet intensity within, like vast cosmic furnaces wrapped in drifting layers of velvet light. And from this glowing heart, light continues its journey outward, softened by the star's gentle touch. Fact 23. Luminosity that moves like a tide. Stephenson 2-18's brightness isn't constant. It rises and falls in slow, rhythmic swells, almost like the tides of an unseen cosmic ocean. These shifts are subtle and unhurried, caused by changes in the star's outer layers as they expand, contract, and breathe with the rhythm of convection. To distant observers, the star may seem to flicker, but its flicker is not a spark. It is a long, dreamy pulse, sometimes taking months to complete a cycle. These variations reveal the dynamic nature of its vast surface, reminding astronomers that even giants have gentle moods. Its luminosity drifts softly, a cosmic heartbeat barely perceptible across thousands of light years. And with each pulse, the star's story deepens, revealing layers of calm complexity. Fact 24. A star that shines through dust. Stephenson 2-18 lies hidden behind thick clouds of interstellar dust, which scatter and absorb much of its visible light. Yet despite this dimming veil, its glow still reaches us across the galaxy. Most of the light we see comes not through the visible spectrum, but through infrared wavelengths, light that slips more easily through cosmic dust. This means that to the naked eye, the star remains invisible, its brilliance muted by the universe's soft shadows. But to an infrared telescope, Stephenson 2-18 glows like a red lantern in a foggy night, its warmth piercing through the darkness with gentle persistence. It reminds us that even when hidden, a star can still shine. And beyond that dusty curtain, more wonders drift quietly into view. Fact 25. Warm light in a cold universe space is unimaginably cold, a silent ocean where temperatures can fall to just a few degrees above absolute zero. And yet, across this frozen expanse, the warm glow of Stephenson 2-18 drifts like a soft lantern light. Its gentle red radiance brings a sense of comfort to the surrounding darkness, filling nearby regions with a faint, nurturing warmth. Though its heat weakens with distance, the light still carries a quiet message. Even in the coldest reaches of the cosmos, warmth can travel freely. The star's rays stretch outward for thousands of years, warming dust clouds, touching neighboring stars, and eventually finding their way to us. And with each soft beam, the universe feels just a little less cold. Fact 26. The patterns of a red supergiant surface. The surface of Stephenson 2-18 is not smooth or uniform. It's a landscape of vast, shifting cells of rising and falling gas. These convective patterns can be larger than entire planetary systems, glowing softly as they move. From a distance, the star's surface might resemble a mosaic of dim and bright patches, each one slowly drifting in graceful, swirling rhythm. Because the star is so large and its outer layers so diffuse, these patterns change slowly, sometimes taking months or even years to evolve. The result is a surface that feels alive, breathing in slow motion, glowing with gentle unpredictability. If you could watch it for long enough, you'd see these shapes drift and shift, like warm clouds rolling across an endless red sky. And beyond those drifting shapes, more mysteries wait to be seen. Fact 27. Flickers in deep space. Even the most peaceful stars experience moments of subtle variability, and Stephenson 2-18 is no exception. Small changes in temperature, convection, or the star's outer atmosphere can cause gentle flickers in brightness. Tiny ripples against the calm sea of its light. These flickers are too slow and too soft for human eyes to notice, but sensitive instruments can detect their delicate rhythms. Each variation is a whisper from the star's interior, revealing how energy moves through its enormous body. The flickers tell astronomers about the star's temperature, its size, and the complex life unfolding deep within its layers. And as each faint shimmer escapes into the galaxy, it becomes another quiet clue drifting through the dark. Beyond that faint shimmer, the story continues with more soft cosmic light. Fact 28. Brightness. Hidden in cosmic fog, Stephenson 2-18 shines with tremendous luminosity, but much of its brightness is muffled by the dense clouds of dust that surround its cluster. These dust grains scatter and absorb visible light, turning the star's glow into a gentle, diffuse radiance by the time it reaches us. What we see is only a small whisper of its true brilliance, a softened echo shaped by the fog of interstellar space. But this dimming doesn't diminish the star's presence. Instead, it wraps the giant in a calming veil, giving it a quiet, mysterious beauty. It becomes a lantern glimpsed through mist, steady and unwavering, its full light hidden, yet still unmistakably warm. And beyond that hazy curtain, the star's true power continues to shine with serene patience. Fact 29. How we measure its glow. Measuring the luminosity of Stephenson 2-18 requires observing it in wavelengths that can slip through the dust surrounding it. Infrared detectors, sensitive to warm light, reveal details that ordinary telescopes cannot. By studying the color and intensity of this infrared glow, astronomers can estimate how much energy the star produces, even if most of its light is veiled from our eyes. They compare its brightness to models of how red supergiants behave, adjusting for distance and dust to uncover its true radiance. It's a bit like listening for a muffled voice in another room, using the tone and warmth to understand the words you cannot fully hear. Through these patient methods, a clearer picture of the star emerges, shining gently across time and space. And from that clearer picture, the next layers of its story begin to unfold. Fact 30. The subtle pulse of a dying giant. As Stephenson 2-18 nears the later phases of its life, its outer layers move with a soft, restless energy. The star gently swells and settles, brightens and dims, as it adjusts to changes deep within its core. These pulsations are not sudden or dramatic. They unfold like the slow breathing of a sleeping giant. Each pulse carries information about the star's structure, clues to the temperature, density, and flow of energy within. To astronomers, these rhythmic whispers are signs of a star approaching the quiet twilight of its lifespan, continuing to shine even as it gradually transforms. And with each slow, tender pulse, Stephenson 2-18 drifts further along its ancient path through the cosmos. Beyond that quiet breath, new wonders begin to emerge in the star's surrounding world. Fact 31. A kingdom of red supergiants. Stephenson 2, the cluster that Stephenson 2-18 calls home, is remarkably rich in red supergiants, far more than most star clusters ever contain. It's as if this region of the galaxy decided to grow an entire family of giants, each one glowing with deep crimson light. These stars are massive, ancient, and nearing the later chapters of their lives, creating a kind of quiet, celestial kingdom where every resident is vast and radiant. In this warm gathering, Stephenson 2-18 stands as the largest of all, but not as a ruler, more like an elder among elders, drifting peacefully alongside its luminous companions. Together, they fill the cluster with a soft reddish glow, blending their light in a tapestry of gentle fire. And beyond this kingdom of giants, the cluster spreads like a cosmic garden. Fact 32. The dense heart of Stephenson 2. Star clusters often disperse over time, their members drifting apart across the galaxy. But Stephenson 2 remains tightly packed, its stars nestle closely in a shared gravitational bond. This dense heart gives the region a sense of intimacy, a place where massive stars grow up together, evolve together, and eventually fade together. In such close quarters, the radiation and winds from each star interact, shaping the environment in subtle ways. Dust clouds shift, gas flows, and light reflects in patterns found nowhere else. For a star like Stephenson 218, this dense neighborhood means companionship throughout its entire life, its light mingling constantly with the glow of its neighbors. Within this closeness, the cluster feels like a cosmic family, shining together in the quiet dark. And just beyond this crowded center, more wonders drift in gentle formation. Fact 33, a cluster rich in heavy stars. Most star clusters contain a mix of small, medium, and large stars, but Stephenson 2 is unusual. It holds an abundance of heavy, massive stars, each destined for a brief, brilliant existence. These stars burn hot and fast, their lifespans measured in millions rather than billions of years. Their combined energy shapes the cluster's environment, filling it with warm light and powerful winds. Because of these heavy stars, the cluster becomes a kind of stellar foundry, forging the elements that will one day drift into new systems, new planets, and perhaps even new forms of life. Stephenson 218, as one of the most massive members, plays a central role in this cosmic cycle. And from this gathering of heavy stars, the galaxy receives materials for its future stories. Fact 34. Dust lanes like soft shadows. The region surrounding Stephenson 218 is threaded with dust lanes, long, delicate ribbons of interstellar material that drift like soft shadows through the cluster. These lanes dim and scatter light, creating pockets of darkness that contrast beautifully with the warm glow of nearby giants. Through them, the starlight seeps gently, giving the entire cluster a muted, peaceful quality, as though wrapped in a cosmic dusk. These shadows are not empty spaces, but nurseries of future stars, filled with the raw materials of creation. The dust absorbs light, warms slowly, and radiates softly in return, adding to the cluster's quiet ambiance. And between these drifting lanes, the giant star's red glow continues to shimmer like a lantern behind velvet curtains. Fact 35. Winds, whispering through the cluster. Every massive star in Stephenson 2 releases streams of gas and particles into the surrounding space, creating a subtle, ever-shifting wind that drifts through the cluster. These stellar winds weave together, forming a gentle current that carries dust and gas in slow, sweeping motions. Though miles per second in speed, they unfold across such vast distances that the effect feels serene, more like a breeze than a storm. Stephenson 218 contributes heavily to this cosmic wind, shedding its material in a quiet outward flow. Over time, these winds sculpt the environment, thinning dust here, gathering it there, shaping the cluster's delicate structures. And within this shared breath, the stars communicate in the soft language of light and motion. Fact 36. Stars, born from the same cloud. Every star in Stephenson 2, including the enormous Stephenson 218, was once part of the same ancient molecular cloud. This means they share a kind of cosmic kinship, formed from the same reservoir of gas and dust. Though each star followed its own path, growing small or swollen, bright or dim, they all carry the same chemical fingerprint from their shared beginning. This familial link gives the cluster a quiet harmony. Its stars move together through the galaxy, bound not only by gravity, but by origin. Stephenson 218, despite its extraordinary size, is simply one member of this stellar family, shaped by the same cradle and carried forward by the same motion. And from this shared beginning, their stories drift outward in gentle parallel across the ages. Fact 37. The quiet crowd around the giant. Stephenson 2:18 does not drift alone in the darkness. It is surrounded by hundreds of companion stars that share its journey through the galaxy. Some are small and steady, shining with gentle constancy, while others are massive and bright, nearing their own transformations into red supergiants. Together, they form a peaceful crowd of celestial lights, each star adding its own soft glow to the tapestry of the cluster. This close companionship means that Stephenson 2:18 is never isolated. The lights of its neighbors mingle with its own, creating a shared illumination that fills the region with warm, overlapping radiance. If you could drift through this cluster, the sky would shimmer with layers of red and gold. And beyond this quiet gathering, the cluster stretches into still deeper calm. Fact 38. Light shared among neighbors. In a dense cluster like Stephenson 2, the light from each star blends with the glow of those around it. Stephenson 2:18 contributes a deep, warm red, while its neighbors add shades of orange, gold, and soft white. These combined hues bathe the surrounding dust in a gentle, multicolored glow, like a distant, eternal sunrise. Light travels freely within the cluster, bouncing off drifting particles and softly illuminating star after star. This shared brightness helps astronomers understand how closely packed the giants truly are. Their light does not travel alone, but mingles in quiet companionship. It's a reminder that even stars, vast as they are, exist not in solitude, but in gentle, glowing community. And through that shared light, the cluster tells a story of cosmic togetherness. Fact 39. A region thick with stellar stories. Stephenson 2 is more than just a cluster. It is a library of stellar stories, each star at a different chapter of its life. Some have only just begun to shine, while others, like Stephenson 2:18, are well into their final phases. The dust, the winds, the shifting shapes of starlight all record the passage of time in ways no book could ever capture. Astronomers study this region to understand how massive stars evolve, interact, and eventually fade. Every star offers a hint, a clue, a whisper about the cycles that shape our galaxy. And because these stars form together, their shared history makes this cluster a rare and precious window into stellar evolution. And beyond these stories, more secrets drift silently in the warm glow of the cluster. Fact 40. The soft choreography of the cluster. Within Stephenson 2, every star follows its own path, yet all are connected by a shared gravitational dance. They drift together through the galaxy in a slow, coordinated motion, like lanterns floating down a peaceful river. This soft choreography makes the cluster feel alive, a community of stars moving with unspoken harmony. Though each star shines independently, their collective motion creates a rhythm that echoes across millions of years. Stephenson 2:18, despite its colossal size, glides gently along with the rest, carried by the same invisible currents. Its light contributes to the cluster's glowing warmth, a steady ember among many. And as the cluster drifts onward, its stars continue this quiet dance across the vast, dark sea of the Milky Way. Fact 41. A star in the constellation Scutum from Earth. Stephenson 2:18 lies in the direction of Scutum, a small, shield-shaped constellation in the southern sky. Though the star is far too distant and too shrouded in dust to see with the naked eye, astronomers know its home lies behind this celestial pattern. Scutum itself is faint, often overlooked, but it quietly shelters some of the galaxy's most remarkable treasures. When we look toward Scutum, we are peering into a dense region of the Milky Way's inner structure, rich with stars, clusters, and drifting clouds. Stephenson 2-18 resides in this busy galactic neighborhood, hidden behind veils of dust, but still detectable through patient observation. And beyond that unassuming constellation, the giant star's warm glow continues its steady journey toward us. Fact 42. Sorrows of measuring faraway light. Even with powerful tools, measuring the distance and brightness of Stephenson 2-18 is a challenge. Dust dims its light, distance distorts its apparent size, and the blurred edges of a red supergiant make precise measurements difficult. Astronomers often describe these uncertainties as the sorrows of studying distant stars. Not sadness, but the gentle frustration of working with incomplete clues. The star's light must travel thousands of years, passing through clouds, gas, and magnetic fields, each layer stealing a little clarity. What reaches Earth is softened, muted, and transformed. Scientists must reconstruct the star's true nature using models, comparisons, and patient analysis. Yet even through these challenges, a remarkable picture emerges, one of the largest, warmest giants ever discovered. And beyond those sorrows, the star's quiet truths continue to shimmer through the dark. Fact 43. Why some stars are hard to see. Even though Stephenson 2-18 is extraordinarily luminous, it remains hidden from our eyes because of the dense clouds of dust between us and the cluster. Dust grains scatter blue light most efficiently, leaving only the deeper reds and infrared wavelengths able to pass through. To human vision, this means the star fades into invisibility, its brilliance lost behind a cosmic curtain. This is why many of the galaxy's largest and brightest stars go unnoticed. They shine with astonishing power, yet the Milky Way's dust lanes weave soft, shadowy veils that obscure even the grandest of lights. Only special instruments can reveal their hidden glow, translating infrared whispers into human understanding. And behind that quiet invisibility, Stephenson 2-18 continues shining gently, unseen but unforgotten. Fact 44. Mapping through dust and darkness. Astronomers use a range of tools to map stars that lie behind thick dust clouds. Infrared telescopes peer through the darkness, radio waves trace gas clouds, and mathematical models predict how dust absorbs and reddens starlight. When studying Stephenson 2-18, these methods come together like pieces of a quiet puzzle spread across the night. By measuring how much the star's light is dimmed or reddened, scientists estimate the thickness of the dust between us and the cluster. This information helps refine the star's true brightness, size, and distance. It's a delicate process, like navigating a misty landscape by the faint glow of a lantern. Through patience and gentle persistence, the hidden shape of the giant slowly emerges. And beyond that unveiling, deeper layers of the galaxy reveal themselves in soft, steady detail. Fact 45. A journey of thousands of years. The light we see from Stephenson 2-18 began its journey long before human history was written. Traveling at the speed of light, it took thousands of years to reach Earth, drifting past clouds, through clusters, and across the spiral arms of the Milky Way. Every moment of its voyage was shaped by the quiet structure of space itself. By the time this light touches our telescopes, the star has already changed. What we observe is an echo of the past, a snapshot of a moment long gone. Stephenson 2D18 may have pulsed brighter or dimmed slightly since then. It may have shed more of its stellar wind or shifted gently in color. Yet the light continues arriving with perfect calm, carrying the star's ancient story across the dark. And beyond that long journey, more light is already on its way, drifting ever closer to our waiting eyes. Fact 46. How distance softens the view. Even the brightest stars lose much of their brilliance over great distances. Stephenson 218 lies so far from Earth that its immense glow becomes a faint whisper by the time it reaches us. Every additional light year acts like another thin curtain, softening the star's appearance until it becomes a gentle shimmer rather than a brilliant beacon. This softening isn't a loss, it's a transformation. The star's overwhelming radiance is filtered into something tranquil, a quiet glow drifting through the universe with delicate calm. What could be blinding up close becomes peaceful from afar, allowing us to observe the giant without harshness. And through that softened light, we sense the true, serene scale of the cosmos. Fact 47. Peering through interstellar veils. To study a star hidden behind dust and distance, astronomers look not only at the light it emits, but also at what happens to that light along the way. Dust grains absorb certain wavelengths. Gas clouds imprint subtle fingerprints on the spectrum, and magnetic fields bend and scatter the starlight. By decoding these changes, scientists can reconstruct the path the light has traveled. It's like reading a letter that has passed through many hands, each adding a faint mark, a tiny crease, a change in color. Stephenson 218's light carries these signatures, offering clues about the structure of the Milky Way and the hidden landscapes between stars. Each veil it passes through adds quiet detail to its story, enriching our understanding with gentle complexity. And beyond those veils, the star's steady glow continues its ancient trek toward us. Fact 48. A faraway lantern in a thick sky. In the dense regions of our galaxy, stars crowd together, dust drifts in dense sheets, and gas clouds twist into long, shadowed corridors. In this busy environment, Stephenson 218 appears like a faraway lantern, softly glowing through layers of cosmic fog. Its light isn't sharp or piercing, but warm and patient, as though waiting for us to find it. This lantern-like presence is part of what makes the star so enchanting. It doesn't dominate the sky. It doesn't shout for attention. Instead, it offers a steady, calming glow that slips quietly through the noise of the galaxy. Infrared. Telescopes can spot this warm radiance easily, tracing its gentle outline against the dusty background. And from this hidden corner of the Milky Way, the lantern continues to shine, marking its place in the cosmic night. Fact 49. The shapes of roads. Light travels. Light doesn't move through the galaxy in a straight, perfect line. Along the way, it is gently bent by gravity, scattered by dust, and nudged by passing clouds of gas. These influences carve subtle curves into its path, shaping the roads that photons follow across the Milky Way. For the light of Stephenson 218, this journey is especially intricate, weaving through a dense and crowded part of the galaxy. Every detour softens the beam. Every scattering shifts its hue slightly toward red. By the time the light reaches Earth, it has been shaped into a tranquil glow, touched by everything it encountered along the way. Its path becomes a quiet record of cosmic terrains it has crossed, and beyond those winding roads, more light continues drifting toward us from the giant's warm heart. Fact 50. how we know it exists at all. Stephenson. 218 is invisible to the naked eye, hidden behind thick veils of dust and distance. Yet astronomers know it exists because of the gentle clues its light leaves behind. Infrared observations reveal a source so bright, so large, and so cool that it can only be a red supergiant. Spectral fingerprints confirm the elements in its outer layers, while the brightness patterns match what is expected of a star of tremendous size. Even though we cannot see it directly, the evidence forms a soft constellation of truths that point unmistakably toward this giant's presence. It's much like seeing a lantern through thick fog. You may not discern the shape of the lamp itself, but the warm glow tells you it is there. And through that glow, the star emerges quietly from the shadows of space. Fact 51. A star. Too large to last, massive stars burn bright and live briefly, and Stephenson 2-18 is no exception. Its colossal size is a sign that it is in an advanced phase of its life, having already exhausted much of the fuel that once sustained its smaller, younger form. As it expands, its outer layers become fragile, drifting farther from the core and glowing softly with fading heat. A star this large cannot maintain its form forever. Its life is a quiet, luminous rush, a few million years of brilliant existence before the final phases begin. And yet, nothing about this feels hurried. The star's immense scale stretches time in a way that feels peaceful, serene, unhurried. Stephenson 2-18 shines now in its twilight, warm and enormous, a gentle monument in the night. And beyond this twilight, its fate continues to unfold softly in the dark. Fact 52. The luminous heavyweights. Massive stars like Stephenson 2-18 belong to a rare class of cosmic heavyweights. Stars so large and so bright that they shape their surroundings simply by existing. Their intense radiation pushes against nearby dust. Their stellar winds sculpt clouds, and their gravity influences the motions of stars around them. Yet despite their immense power, their presence often feels serene, like gentle giants resting in the deep night. Stephenson 2-18, with its enormous radius and warm red glow, is one of the most luminous of these giants. Even through veils of dust, its energy spills softly into space, warming the cluster with a quiet, steady brilliance. And from this luminous calm, the star continues guiding the environment around it with effortless grace. Fact 53. The slow swelling of a massive heart. As Stephenson 2-18 ages, its core undergoes profound changes. Once dominated by hydrogen fusion, it now relies on heavier elements to fuel its inner fire. Each new stage of fusion creates more energy, pushing outward on the star's outer layers with gradual insistence. The result is a slow, majestic swelling, a gentle expansion that can take thousands of years to unfold. This swelling is not sudden or violent. It is the natural breathing of a massive star nearing its final chapters, growing larger as its core grows denser. The outer layers stretch thin and cool, turning the star into the deep red supergiant we observe today. With each quiet expansion, the star carries itself further into the realm of giants. And beyond this swelling heart, the next steps of its life wait in stillness. Fact 54. How red supergiants breathe. Red supergiants like Stephenson 2-18 seem to breathe, not with lungs, but with cycles of expansion and contraction in their vast outer envelopes. These rhythmic motions are driven by convection, the rising and falling of gas as heat escapes from the layers below. Each cycle can span months or even years, creating a slow pulse that travels across the star's enormous surface. If you could watch it over generations, you'd see its limbs of gas gently lift and settle, like the chest of a resting being. This breathing helps regulate the star's temperature, redistributes energy, and sends soft waves of light across the cosmos. Though invisible in real time, this ancient, steady pulse gives the star a quiet sense of life. And with every soft exhale, Stephenson 2-18 moves one step further along its cosmic journey. Fact 55. The chemistry of dying light. Deep within Stephenson 2-18, new elements are forged in layers stacked like the pages of an ancient book. As hydrogen and helium become scarce, the star begins fusing heavier elements: carbon, oxygen, and eventually even magnesium and neon. Each fusion stage releases energy, but also brings the star closer to the limits of what its heart can sustain. This chemistry isn't violent. It unfolds slowly, with the patience of a star that has known millions of years. The elements formed within its core will one day drift into space, becoming part of nebulae, planets, and perhaps even life. For now, though, they remain cradled inside the giant, shaping its warmth and color. And from this quiet alchemy, the star's soft red glow deepens, rich with the imprint of its inner fire. Fact 56. Convection that moves like weather. The surface of Stephenson 2-18 is ruled by convection, the rise and fall of hot gas in patterns so large they feel like entire worlds in motion. These convective cells behave like slow-moving weather systems, rolling gently across the star's surface. Some swell upward like luminous hills. Others sink like cooling valleys, all shifting with a rhythm older than human history. Because the star is so enormous, each cell can stretch millions of kilometers across. Their movements create subtle changes in brightness, a flickering pattern that tells astronomers about the dynamics hidden beneath the surface. This convection is the star's way of releasing energy, distributing heat through its diffuse atmosphere with elegant restraint. And as these vast currents drift, they give the giant a soft, pulsing life of its own. Fact 57. A surface in constant change. Though it may appear calm from afar, the exterior of Stephenson 2-18 is always changing. Its thin outer layers shift like drifting mist, shaping new patterns of brightness and temperature. These changes unfold slowly, taking months or even years to complete, making the star feel timeless, a being whose movements are too serene for human eyes to track. This constant change is a sign of the star's advanced age. As its core evolves, the outer layers respond, expanding and contracting gently. Sometimes a patch of the surface grows warmer and brightens. Sometimes it cools and dims, like a glowing coal settling deeper into the embers. Through all of this, the star remains steady in its identity, vast, warm, and quietly radiant. And beyond these subtle changes, deeper stories wait within its drifting layers. Fact 58. The quiet turbulence of the outer layers. Even though Stephenson 2-18 appears serene, its outer layers are filled with gentle turbulence, slow rivers of gas drifting in sprawling, luminous loops. These motions are driven by the star's vast energy leaking outward, shaping the atmosphere into patterns that shift with unhurried grace. To us, these movements seem peaceful, but within the star, they are part of a delicate, ongoing balancing act. The gas rises warm from the depths, cools as it spreads outward, and eventually sinks again, creating a cycle that repeats endlessly. This quiet turbulence is essential to the star's life, carrying energy from the core to the surface in broad, continuous waves. And with every drifting current, the giant breathes its ancient warmth into the universe. Fact 59. The path to core exhaustion. As stars like Stephenson 218 age, their cores steadily run out of fuel. First hydrogen fades, then helium, and eventually even heavier elements begin to dwindle. Each new stage of fusion burns faster than the last, leaving the star with less time and a growing sense of cosmic weariness. Yet the process unfolds with a calm inevitability, not abrupt, but measured, like pages turning in an immense celestial diary. The core grows denser and hotter as it struggles to support the weight above it. Meanwhile, the outer layers drift farther outward, thinning into soft, glowing clouds. The star becomes larger, cooler, and more fragile, carrying the signs of its slow internal transformation. And as this path deepens, the giant approaches the final chapters of its long, luminous story. Fact 60. Why giants live such short lives. It may seem surprising that the largest stars live the shortest lives, but their immense energy demands rush them through their fuel far more quickly than smaller stars ever experience. Stephenson 2-18 shines with such extraordinary brightness that it burns through its nuclear reserves at a breathtaking pace. What the sun will take billions of years to consume, a star like this uses in mere millions. Yet this brevity does not feel hurried. From our perspective, the star's life unfolds in slow, majestic waves, expansions that last centuries, pulses that flow through its surface like tides across a quiet sea. Its short lifespan is still far longer than all of human history, long enough to feel timeless and serene. And beyond this fleeting but beautiful existence, the star's future waits softly in the dimming glow. Fact 61. Heavy, yet gentle in glow. Stephenson 218 is unimaginably massive, many times heavier than our sun, yet its appearance is soft, almost tender. Its outer layers are so cool and diffuse that they glow with a warm, velvety light rather than a harsh brilliance. This contrast is part of the quiet magic of red supergiants, immense power wrapped in gentle radiance. Despite its mass, the star feels weightless to an observer watching from afar. Its gases drift outward like glowing mist, and its surface moves in slow tides rather than sharp bursts. It is a reminder that size and ferocity do not always go hand in hand. Some of the universe's largest beings are also its calmest. And from this graceful heaviness, Stephenson 2-18 continues to shine with deep, quiet warmth. Fact 62. How mass shapes a star's destiny. The fate of a star is determined almost entirely by its mass at birth. Small stars burn slowly and live for billions of years, while massive ones like Stephenson 2-18 blaze rapidly and expand dramatically as they age. Because it began with so much material, the star's core reached incredible temperatures early in its life, driving it swiftly through its stages of fusion. Its mass destined it to become a supergiant, destined it to shine fiercely, and destined it to end in a powerful transformation that will one day scatter its elements into the galaxy. Mass is both a gift and a burden, the key to a star's brilliance and the reason it cannot last. And as Stephenson 2-18 moves toward its eventual fate, its mass continues to guide each gentle step of its journey. Fact 63. The binding of a massive core. At the center of Stephenson 2-18 lies a core held together by extraordinary pressure. Gravity pulls inward with immense strength, squeezing the core until atoms are crushed closely enough to spark new rounds of fusion. This binding force is what allows the star to shine, a balance between collapse and expansion that keeps the giant suspended in its luminous form. But as the star ages, this core becomes hotter, denser, and increasingly strained. Each new element it fuses lasts for less time than the one before, forcing the core to work harder to hold everything together. Eventually, even this massive core will reach a point where it can no longer support the weight above it. For now, though, it remains steady, a quiet furnace at the heart of a drifting red lantern. And beyond this bound core, deeper changes continue to unfold softly within. Fact 64. The rate at which it burns. Stephenson 2-18 burns its fuel at an astonishing pace, far faster than stars like our Sun. Because of its immense mass, the pressure inside its core is so intense that fusion proceeds rapidly, releasing energy in great waves that ripple outward through its vast layers. This quick burning is what gives the star its extraordinary brightness and its brief lifespan. Yet from a distance, nothing about this rapid burning feels rushed. The star's light emerges slowly, softened by the long journey from core to surface. What looks like urgency inside becomes tranquility outside, a peaceful glow shaped by millions of kilometers of drifting gas. And through that patient glow, the star reveals its delicate balance between power and calm. Fact 65. The slow collapse within. As Stephenson 2-18 ages, its core becomes a place of quiet tension. After each stage of fusion ends, gravity begins to pull inward again, compressing the remaining material ever more tightly. This slow, inward collapse is invisible from the outside, hidden beneath the star's vast glowing layers, but it sets the stage for all that will come next. The outer layers respond gently, expanding in slow, sweeping motions as the core contracts. The star grows larger, while the center grows denser, like a lantern whose flame is shrinking even as its light grows more diffuse. This delicate interplay continues for thousands of years, each moment nudging the star closer toward its final transformation. And through this unseen collapse, the giant maintains its serene presence in the night. Fact 66. Helium, carbon, and the dance of fusion. Inside Stephenson 2-18, fusion takes place in layers, each burning a different element in turn. After hydrogen is exhausted, helium becomes the primary fuel. When helium fades, carbon and oxygen take their place. Each new stage burns hotter, lasts shorter, and demands more from the star's shrinking core. This sequence of fusion stages is often described as a dance, one step leading gracefully into the next. But in a red supergiant like Stephenson 2-18, the dance is slow and dreamlike, unfolding over centuries. The layers ignite gently, one after another, creating a complex, glowing interior structure, like softly stacked shells radiating heat into the surrounding vastness. And beyond these burning layers, the star's outer glow remains warm and reassuring, hiding the complexity within. Fact 67. What happens in deep, hidden layers? Beneath the glowing surface of Stephenson 2-18 lies a world we cannot directly see. Layers of gas compressed and heated into luminous shells of fusion. Each layer burns a different element, creating an intricate nested structure that resembles the rings of a vast cosmic tree. But unlike a tree, these layers are always shifting, responding to changes in temperature, pressure, and the star's slowly contracting core. Inside these hidden regions, time seems to move differently. Energy produced in the core takes thousands of years to reach the surface, drifting upward in slow waves. By the time it emerges as the soft red light we observe, its journey has smoothed away all traces of the turbulence below, And from those deep, unseen layers, the star continues weaving its quiet story of fire and patience. Fact 68. Why the star expands so widely. As Stephenson 2 to 18 ages, its core becomes incredibly hot and dense, while its outer layers become loosely bound and easily pushed outward. The immense energy produced inside the core flows upward, inflating the giant's atmosphere like a slow, shimmering balloon. But this expansion isn't sudden. It unfolds gently over thousands of years, as though the star is stretching into a more relaxed and peaceful shape. The farther the outer layers drift, the cooler they become, giving the star its soft red hue. Eventually, the atmosphere grows so extended that it becomes almost translucent, more like a warm, glowing fog than a solid sphere. This is the hallmark of a red supergiant at its fullest bloom. And through this gentle expansion, the star reaches the breathtaking size that makes it one of the largest ever found. Fact 69. The seasons of a supergiant. Though stars do not have seasons as planets do, red supergiants experience long, slow cycles that resemble changes in mood. Over years or decades, Stephenson 218 may grow slightly brighter or dimmer, slightly warmer or cooler, as its outer layers shift in response to the changes unfolding deep within. These cycles are vast and unhurried, like a cosmic version of seasonal tides. During a warm phase, the star may glow a little more brightly, its surface swelling gently. In a cool phase, the outer layers settle and dim, giving the giant a softer appearance. These subtle variations are signs of the star's living nature, a reminder that even giants breathe in slow rhythms. And beyond these quiet seasons, the star continues drifting calmly toward the next part of its ancient journey. Fact 70. The trembling of a giant. Even a star as vast as Stephenson 2.18 is not perfectly still. Its surface occasionally experiences gentle oscillations, tiny tremors that ripple outward like waves across a calm lake. These vibrations are caused by shifts in temperature and pressure within the star's deep interior. To our instruments, they appear as small, rhythmic changes in brightness, far too delicate for the human eye to notice. These tremors tell astronomers about the star's inner structure, revealing clues about density, temperature, and the layers of fusion occurring far below the surface. It is a form of stellar music, not one we can hear, but one we can measure, like the faint humming of an ancient instrument. And beyond these quiet tremors, the star continues its steady, tranquil glow. Fact 71. How a star holds itself together. Stephenson 2.18 is held together by a delicate balance between two colossal forces. Gravity pulls inward, trying to collapse the star, while the pressure from fusion pushes outward, trying to expand it. This equilibrium is known as hydrostatic balance, and it is what keeps the star suspended in its majestic form. In a stable star, these forces match perfectly, allowing it to maintain its shape over long stretches of time. But in a red supergiant of this scale, the balance is gentle and easily disturbed. When the core shifts, the outer layers respond with slow expansions or soft contractions, like the movements of a drifting cloud. This balance gives the star its quiet poise, a calm that feels almost meditative in the vastness of space. And beyond that balance, the star's future quietly gathers momentum. Fact 72. Life in the atmosphere of a red supergiant. The atmosphere of Stephenson 2.18 is a strange and beautiful place. It is enormous, stretching far into space, and filled with gas so diffuse that it more closely resembles a warm fog than a solid surface. Within this fog, molecules form and break apart in slow, graceful cycles, creating a chemistry that would be impossible on smaller stars. Temperatures here are cool enough for dust grains to condense. Tiny flecks of silicates and metals that drift in soft spirals away from the star. These grains become part of the stellar wind, carrying the star's material outward to someday enrich the galaxy. If you could drift through this atmosphere, you would see shimmering clouds glowing with deep red light, like embers floating in the dark. And beyond this vast and gentle atmosphere, the star's outer winds continue flowing into space, quietly shaping the world around it. Fact 73. A stellar wind that drifts like mist. Stephenson 2-18 releases a steady outflow of gas known as a stellar wind, a gentle stream of particles drifting away from the star and into the surrounding darkness. Unlike the sharp, forceful winds of hotter stars, a red supergiant's wind moves slowly, like a warm mist spreading outward in every direction. Over time, this mist forms a vast halo around the star, glowing faintly with reflected light. These winds carry the star's material into space, grain by grain, atom by atom. What leaves today may one day become part of a distant nebula or a newborn star. In this way, the wind is not just an escape of matter, but a quiet gift to the galaxy. And beyond this drifting mist, the star's influence spreads softly into the cluster. Fact 74. The cloud that grows around a giant. As the stellar wind flows outward, it begins to collect into a circumstellar envelope, a sprawling cloud-like region surrounding Stephenson 2-18. This envelope is made of dust and gas shed from the star's outer layers, illuminated by its deep red light. From afar, it resembles a glowing shell, delicate and ever-changing, shaped by gentle currents and shifting temperatures. Within this cloud, dust grains slowly cool and settle, forming structures that drift like soft shapes in a dream. Some parts of the envelope glow brighter, where fresh material is shed. Others fade quietly as the dust moves farther away. The entire structure is alive with motion, but all of it unfolds in slow, peaceful rhythms. And from within this luminous cocoon, the giant continues to shine with patient calm. Fact 75. The slow farewell of a red giant. Every particle that leaves Stephenson, documentaries, 18's surface is part of a slow, graceful goodbye. Over thousands of years, the star gently releases more and more of its mass, thinning its atmosphere and preparing for the transformation that lies ahead. This shedding is not dramatic or violent. It is a long and quiet process, like a lantern gradually burning down its fuel. As the star loses mass, its outer layers become even more extended and delicate, drifting farther from the core with each passing century. The star becomes lighter, softer, and more transparent, its brilliant life beginning to shift toward its final, luminous chapters. Yet even in this gentle farewell, the star remains a calm beacon, steady and warm, offering light to everything around it. And beyond this soft letting go, the next phase of the star's journey waits in peaceful stillness. Fact 76. Material released into the cluster. The gas and dust that drift away from Stephenson 2-18 do not vanish into emptiness. Instead, they slowly join the wider environment of the Stephenson 2 cluster, blending with the clouds and currents already flowing there. Over thousands of years, this material becomes part of a rich mixture that surrounds the cluster, a quiet reservoir of elements forged in the hearts of massive stars. Some of this material will cool and settle into the cluster's outer regions. Some will be pushed along by stellar winds from neighboring giants. Some will eventually collapse into dense knots that may one day ignite as new stars. It is a cycle of giving and renewal that moves with unhurried grace. And as its material drifts outward, Stephenson 218 quietly nourishes the future of its cosmic home. Fact 77. How supergiants feed future stars. Massive red supergiants play an essential role in seeding the galaxy with the ingredients needed for future generations of stars and planets. The elements they create, carbon, oxygen, magnesium, and more, are carried outward by their winds and later spread even farther by their final explosive endings. Over millions of years, this enriched material mixes with pristine hydrogen clouds, forming fertile nurseries for new stars. Stephenson 2-18 is actively participating in this slow, generous process. Every atom it releases becomes part of a vast cosmic tapestry, drifting across space until gravity, time, and chance gather it into a new beginning. Even long after the star is gone, its influence will live on through the stars and worlds it helped create. And from this patient giving, the galaxy grows ever more vibrant with each passing era. Fact 78. Heavy elements spread with quiet grace. Although we often imagine the dispersal of heavy elements as something sudden or dramatic, much of the process happens gently. For a star like Stephenson 218, most of the spreading occurs through its soft, continuous stellar wind, a slow release of enriched gas that spreads outward like ripples on a still lake. These atoms drift through space for ages, carried by gentle currents of interstellar gas. Some may wander for thousands of light years before joining new clouds. Others may remain close to the cluster, circling quietly until they find a home in a future star system. Their motion is unhurried, guided only by the faintest of cosmic breezes. And through this gentle dispersal, Stephenson 218 shares its legacy with the entire Milky Way. Fact 79. A cluster enriched by its giants. The Stephenson 2 cluster is not just a gathering of bright stars. It is a living ecosystem, continually enriched by the giants within it. Every red supergiant contributes its own blend of newly forged elements, releasing them slowly into the shared environment. Over time, this material accumulates, giving the cluster a warm, elemental richness that younger clusters often lack. Stephenson 2-18, being one of the most massive members, adds significantly to this enrichment. Its winds carry carbon, oxygen, and other heavy elements that will eventually become part of the cluster's next generation of stars. In this way, the cluster becomes a cradle for future creations, shaped gently by the lives of today's giants. And from this enriched cradle, the seeds of future stars rest quietly, waiting for their moment to shine. Fact 80. A giant with no known companions. Many stars form in pairs or trios, bound together by gravity. But Stephenson 2-18 appears to be a solitary giant, drifting through the cluster without a close stellar companion. This solitude is not unusual for massive stars at advanced ages. Their enormous winds and shifting outer layers can make it difficult for smaller companions to remain in stable orbits. Being alone allows the star to expand freely, without the gravitational tug of a nearby neighbor shaping its enormous atmosphere. It also means the material it sheds spreads evenly into the surrounding space, forming a broad, gentle halo instead of spiral patterns. In its solitude, Stephenson 2-18 glows quietly, a peaceful lantern surrounded by distant stellar brethren. And beyond this solitary calm, the cluster continues to hold the star in its wide, gentle embrace. Fact 81. Why high-mass stars rarely form. Close duos, Stars as massive as Stephenson 2 at 18 often form in chaotic environments where gravity, collisions, and turbulence shape their early lives. Smaller stars frequently end up in binary pairs, but giants of this scale typically avoid close partners. Their powerful radiation and winds push material away during formation, preventing neighboring stars from settling into stable orbits. Even if a companion did form nearby, the giant's rapid expansion later in life would likely disrupt the duo, either sweeping the smaller star outward or engulfing it entirely. Over millions of years, these forces encourage high-mass stars to live solitary lives, even in crowded clusters. Thus, Stephenson 2.18's isolation is not loneliness. It is the natural, peaceful outcome of its immense size and gentle cosmic influence. And beyond this solitary path, the star's quiet evolution continues, touched only by the cluster's distant glow. Fact 82. Why giants live quietly alone. High-mass stars like Stephenson 2.18 often spend their lives without close companions, not because companionship is rare in the universe, but because their immense size and shifting atmospheres make it difficult for any smaller star to stay safely nearby. Their outer layers drift so widely that even a distant orbit could someday fall within their swelling reach. Over time, these giants become surrounded not by close partners, but by gentle halos of gas and dust they have shed. Their solitude becomes a natural part of their evolution, a quiet stage where they can expand, breathe, and glow freely. Stephenson 2.18 lives this solitary life with serene dignity, alone but never lonely, held in the soft company of the cluster around it. And beyond its solitary glow, the next stories of its interior continue unfolding. Fact 83. The heat, hidden in the star's center. Though Stephenson 2.18's surface is cool and calm, its core is unimaginably hot. A place where temperatures soar into the tens of millions of degrees. This inner furnace is what powers the star, fusing heavier and heavier elements as it ages. The contrast between the peaceful exterior and the intense heart is one of the great paradoxes of red supergiants. Energy produced in the core takes thousands of years to reach the surface, drifting outward in soft, gradual currents. By the time it emerges, all the violence of fusion has been smoothed away, softened into a gentle red glow. It is as if the star hides its fire deep within, choosing to show the universe only its warmest, most tranquil face. And beneath that tranquil face, the core continues its slow, determined work. Fact 84. Creating elements in quiet layers. Inside Stephenson 2.18, fusion unfolds in concentric shells, hydrogen burning on the outside, then helium, then carbon, each deeper layer hotter and more compressed than the one above. These shells form a beautiful, structured interior, like the rings of a cosmic onion glowing softly from within. As each layer burns, it creates new elements and releases energy that drifts outward to support the star's vast form. Even as the star approaches the later chapters of its life, these layers continue working in gentle harmony, one stage handing off to the next. The result is a quiet masterpiece of stellar engineering, an interior built by time, pressure, and patience. And beyond these glowing shells, the outer atmosphere drifts peacefully through the darkness. Fact 85. A star approaching its twilight. Stephenson 2.18 is in the last peaceful chapters of its life. Though this phase spans hundreds of thousands of years, it is still considered twilight for a star of such great mass. Its core is nearly out of lighter elements to burn, and each new stage of fusion grows shorter, hotter, and more demanding. Yet from the outside, nothing feels rushed. The star continues to glow with steady, gentle radiance. As the core evolves, the outer layers expand farther, becoming more delicate, more luminous, and more diffuse. The star appears almost dreamlike in this stage, like a lantern made of warm fog, shining softly through the cluster's darkness. And through this twilight glow, the star drifts calmly toward the next quiet phase of its journey. Fact 86. The layers that will someday drift away. In its final stages, Stephenson 2-18 will shed its outer layers completely, releasing enormous clouds of gas and dust into space. These layers are already loose and extended, held only gently by the star's weakening gravity. Over time, they will detach like soft petals, forming a vast nebula around the remaining core. This nebula will shine faintly with the last echo of the star's energy, illuminated by ultraviolet light from the core's exposed remnant. The shapes that emerge, soft shells, spirals, or billowing clouds, will be crafted by the winds and currents within the star's atmosphere today. Though we will never witness this transformation directly, it is already written into the star's structure, waiting patiently for its moment to unfold. And beyond these drifting future layers, the remaining heart of the star prepares for its final act. Fact 87. A final gift of heavy elements. When Stephenson 2-18 eventually reaches the end of its life, it will leave behind a final legacy, an enormous release of heavy elements forged in its core. Elements such as iron, silicon, and sulfur, the very building blocks of rocky planets and living worlds, will scatter across the galaxy. This enriches the interstellar medium, giving future stars and planets the materials needed for complex chemistry. This final gift is not violent in our imagining here, but peaceful in purpose. A return of everything the star has created over millions of years. The material will travel far, drifting into new clouds, mixing with pristine hydrogen, and ultimately forming the seeds of distant futures. And beyond this quiet legacy, the universe continues its gentle cycle of creation and renewal. Fact 88. The heart that will one day collapse. Deep inside Stephenson 2-18, the core grows heavier with every passing era. Each fusion stage creates elements that cannot be burned for long, and eventually the core becomes dominated by iron, an element that cannot release energy through fusion. When this point is reached, the delicate balance between pressure and gravity begins to tip. The core will slowly lose its ability to support the immense weight above it, and gravity will start to draw everything inward. But from the outside, nothing seems to change. The star continues glowing softly, its surface drifting in calm, rosy light. Only in its deepest layers does the quiet shift begin. This is the beginning of the final chapter, written in silence at the center of a star. And beyond that hidden collapse, the future waits in stillness. Fact 89. A supernova, waiting in the winged stars, as massive as Stephenson 2-18, are destined to end their lives in supernovae. Immense outbursts that scatter their heavy elements into the galaxy. Yet the moment itself is not one of violence to imagine before sleep. Instead, think of it as a transformation, the peaceful release of everything the star has carried for millions of years. When the time comes, the outer layers will drift away into space, glowing softly as they move. The core will contract, then change into something new. Perhaps a neutron star, perhaps a black hole, depending on the final mass. What remains will be serene, a faint ember or a quiet well of gravity resting where the giant once shone. And beyond this transformation, the cluster will continue its slow, starry drift through time. Fact 90. A legacy that echoes through the galaxy. Even after Stephenson 2-18 is gone, its presence will continue to echo through the Milky Way. The dust it shed will float through star-forming regions. The elements it forged will become part of future suns, moons, oceans, and perhaps even living beings. Its enriched material may one day sparkle in the rings of a young planet, or swirl in the clouds of a faraway world. The cluster itself will carry the memory of this giant, a star that stretched across astronomical units, glowing with quiet warmth and gentle grandeur. And though we will never see its final moments, its legacy is already scattered throughout its surroundings. From the star's soft red glow to the elements it leaves behind, Stephenson 2-18 becomes part of the universe's endless cycle of renewal. And beyond that legacy, a few final sleepy facts still wait in the gentle night. Fact 91. The cluster, after the giant fades. Long after Stephenson 2-18 completes its life, the Stephenson 2 cluster will continue drifting peacefully through the Milky Way. New stars will form from the enriched materials left behind, while older stars quietly evolve at their own unhurried pace. The memory of the giant will linger in the shimmering dust, in the chemistry of new suns, and in the warmth of the nebulae that follow. Though the cluster will eventually disperse, as all clusters do, some of its stars will remain gravitational siblings, wandering the galaxy together for billions of years. In their elemental makeup will lie a subtle signature, a soft whisper of the giant that once glowed among them. And as they journey onward, the cluster carries an echo of Stephenson 2-18 into the deep future. Fact 92. The black hole possibility. Given its extraordinary mass, Stephenson 2-18 may one day collapse into a black hole, a quiet, compact remnant where gravity becomes so strong that not even light can escape. Yet imagining this fate need not be frightening. Think of it instead as a serene transformation, the star's final shape becoming a perfectly still point of gravity in the dark. Such a remnant would not shine or flicker. It would simply exist, calm and unassuming, influencing the motions of nearby stars with its gentle pull. Over millions of years, dust and gas may drift near it, circling softly before continuing their path through the cluster. If this is the star's ultimate destiny, it will be a peaceful one, a quiet anchor where a giant once floated. And beyond that stillness, the galaxy continues its timeless dance. Fact 93. How one star enriches many worlds. The elements forged inside Stephenson 2-18 will not remain in one place. Over vast stretches of time, they will disperse into the galaxy, mixing with ancient clouds and forming new systems. Some of these elements may become the rocky crust of a distant exoplanet. Others may settle into icy moons, drifting through alien skies. Some may even become part of organic molecules on worlds we have yet to imagine. In this way, a single massive star enriches countless future possibilities. Its life may be brief compared to smaller stars, but its contributions are immense, woven into the fabric of countless futures. Stephenson 2-18 becomes a quiet architect of tomorrow's worlds, a gentle giver whose legacy ripples through the cosmos. And beyond these scattered gifts, more sleepy facts wait to complete the journey. Fact 94. The long silence after a giant. When Stephenson 2-18 finally finishes its luminous life, the region around it will fall into a deep cosmic quiet. The soft, Winds that once drifted from its surface will cease, and the warm glow that once illuminated the surrounding dust will fade. In its place will be a gentle stillness, the kind that settles after a long glowing sunset. The remnants left behind, whether a neutron star or a black hole, will sit quietly at the center of a slowly expanding nebula. Over thousands of years, this nebula will stretch like a faint, colorful cloud, scattering the star's memory across the cluster. It is not an ending, but a soft pause, a deep breath held by the universe. And beyond that silence, the galaxy continues its unbroken rhythm. Fact 95. Why these titans are so rare. Stars as large as Stephenson 2-18 are exceedingly rare in the galaxy. They require enormous amounts of gas to form, and the conditions must be just right for such a massive star to ignite. Even among red supergiants, only a handful ever reach this extraordinary size. Their rarity makes each one precious, a fleeting masterpiece in the grand gallery of the cosmos. Because they live such short lives, we observe only a few at any moment. The rest have already faded into their final forms, or have yet to be born in distant clouds. Seeing one like Stephenson 2-18 is like glimpsing a rare blooming flower that appears briefly before vanishing again. And in this rarity lies a gentle beauty, the quiet wonder of encountering something truly singular. Fact 96. The beauty of seeing the unseen. Though Stephenson 2-18 cannot be viewed with the naked eye, its presence is revealed through careful observation in infrared light. This invisible glow paints a picture of the star that our eyes alone could never capture. It reminds us that much of the universe is hidden just beyond our senses, waiting to be discovered with patience and curiosity. Astronomers use this unseen light to trace the star's outline, measure its warmth, and explore its vast atmosphere. Every wavelength carries information, a soft whisper of the star's size, age, and inner workings. In the end, what we know of Stephenson 2-18 is not from looking directly, but from listening closely. And beyond this unseen beauty, a few final facts drift toward us like starlight on a calm night. Fact 97. A star measured by patience. Understanding a star as distant and veiled as Stephenson 2-18 requires extraordinary patience. Astronomers must collect faint fragments of its light across many years, comparing subtle changes and refining their measurements little by little. Each observation adds one quiet brushstroke to a portrait that can never be seen all at once. This patience mirrors the star's own slow evolution. While it changes over thousands of years, our studies take decades, a brief moment compared to the star's lifetime, yet long enough to capture part of its story. Through careful work, we begin to perceive its true enormity, its cool glow, and its gentle rhythm. And through this patient watching, the giant gradually reveals its sleeping beauty. Fact 98. A dim glow that carries a vast story. Although the light from Stephenson 2-18 reaches us as a faint reddened shimmer, it carries an immense story across the deep bones of the galaxy. Each photon that arrives at Earth has traveled thousands of years, slipping past drifting clouds, brushing through dark corridors of dust, and weaving between stars. By the time this softened glow touches our detectors, it brings with it the memory of the star's size, its temperature, and the composition of its outer layers. Light becomes a messenger, gently transporting the history of a giant across the emptiness of space. And in that dim glow lies the quiet echo of a star that once burned brilliantly. Fact 99. A reminder of the universe's scale. Stephenson 2:18 stands as a quiet reminder of how vast the universe truly is. Its radius stretches so far that it would engulf the orbits of planets if placed in our solar system, yet it remains just one star among billions in the Milky Way. Its size challenges our imagination, stretching our sense of scale into new, dreamlike territory. And yet, despite its immensity, its light reaches us only as a tender whisper, a small, gentle shimmer hidden behind curtains of dust. This combination of enormous presence and delicate appearance embodies the paradox of the cosmos, grand beyond measure, but soft and calming in the ways we come to understand it. And beyond this reminder, one final sleepy fact awaits to close our journey. Fact 100, the quiet wonder of a distant giant. Stephenson 2:18 is more than a measurement, a classification, or a record-breaking radius. It is a reminder that the universe holds wonders far beyond our daily reach, silent, distant, and glowing with ancient calm. Though we will never stand near it or see it with our own eyes, its warm red light still finds its way to us across thousands of years, offering a quiet invitation to dream bigger and breathe deeper. In the soft shimmer of this distant giant, we find a gentle truth. Even the largest things in the cosmos can speak in whispers. And in those whispers, carried through dust and time, we hear a story of warmth, patience, and cosmic grace. And with that final glow, our journey comes to its peaceful close. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.